In this lesson we will make a meteor fall on Earth. For this we use a game manager using the Singleton pattern. We learn what steps we need to take to set up a game manager script. We learn how you can see from an error message where the bug is located. And we learn how to use a variable from a GameManager instance in your script. Let's start this lesson. Let's add a sphere in the hierarchy. This is our enemy. In other words, a meteor descending from the sky. To make the sphere visible in the game view, we need to adjust the z-axis. And let's move it a little bit to the top of the screen. Let's create a new script called enemy movement. Here we code how we want the enemy to come down. We can attach this script to our enemy game object. Now that we have two scripts in the project library, it is wise to reorganize things. We can create a new folder called scripts. We can move our two scripts to this new folder. Open the script. We start by declaring a public float variable called enemy speed. We assign this a value in the editor. Then we create a function called moveEnemy. Here we let the enemy descend using transform.Translate with a vector 3.down. Multiplied by the variable enemy speed. Multiplied by time.delta time. And don't forget to call the function in the update method. And save the script. First, we give the enemy speed a value of 5. When we test the game, we see the meteor slowly descending. However, the meteor does not start from the top of the screen, but just below it. That is of course strange. Let's first make the meteor appear at the top of the screen, and only then let it descend towards Earth. Open the enemy movement script. We can again calculate the height and width of the screen, as we did in the player movement script, but that means double work. And game developers don't like duplication of work. We want these calculations to take place in a separate script. We only want to access the height and width of the screen, nothing more. Luckily for us, we can create a game manager script where we can handle this kind of thing. We add a new script that we call Game Manager. Unity gives this a nice icon of a gear. This indicates that this is a special script. We create a Singleton script of our game manager. A Singleton in Unity is a globally accessible class. The idea is that any other script can access the Singleton. A Singleton class holds a public static reference to an instance of its own type. This makes a Singleton globally accessible. Making a variable static means that it is shared by all instances of the class, meaning that any script can access the Singleton through its class name. This means that any public methods or variables that exist in the Singleton class can be accessed by other scripts in the game. That's what we need for our screen height and width variables. While the reference to the script is static, meaning that it is the same in any and all instances of the class, the instance that it points to is not, meaning that while the reference can only ever point to one instance of the script, it's possible to have more than one instance of the singleton in the scene, which is why it's important to make sure that there is only ever one instance of the singleton. If there's a duplicate, it can be deleted. In the wake method, we check whether the instance of the game manager is not null. The wake method is called before the start method is called. This way we can be sure that this check is done first. If the instance is not null, an instance already exists, then it can be destroyed, and we can exit the method with the return statement. If the instance is null, the body of the if statement is not run. Then we can set the instance equal to this script with the statement instance is this. Now we have set the game manager script as a singleton, and we can place the calculation of the screen height and width in our game manager script. First, we copy the variables from the enemy movement script or movement script, and then we copy the actual calculation into the start method of our game manager. We want to access the height and width variables in other scripts. We must make them public. Now we can use the screen height and width variables in the game manager instance in our movement script. We no longer need the calculations for the screen height and width in our movement script, so we can delete them. Since the width variable no longer exists in this script, we have to use the variable from our game manager instance. We can also remove the calculation part in the get and start position function. The height variable also no longer exists, so we must also set it equal to the variable of the game manager instance. And even though we haven't done anything yet with the height and width calculations in the enemy movement script, we can also delete them. If all goes well, everything should still work. But it does not. We get an error message. If we look at the error message, we see that the error is on line 30 of our movement script. We use a variable without a value. Let's see what's going on at line 30. We have removed a bit too much code. The variable size does not have a value. Let's fix this by redoing this statement. But what else could be going on? We have a nice game manager, but we don't apply it to the scene. We need to create an empty game object that we call Game Manager. We can attach our Game Manager script to this object. Now everything works again, but we haven't made much progress. The meteor still doesn't start from the top of the screen. Let's change this quickly. Now that we have access to the screen height through the Game Manager, we can easily start the meteor at the top of the screen. We give the transform.Position in the start method the y value of half the screen height. We leave the x-axis and z-axis at 0. As you can see, when we test this out, the meteor now starts at the top of the screen. Except the meteor just keeps falling until we end the program. If we soon drop several meteors, they will continue to exist even if they fall outside the frame. If we don't do anything about this, this could become a problem, because Unity will have to continue calculating the trajectory of the meteor, while we no longer need this meteor once it reaches the bottom of the screen. We create a function that we call destroyEnemy. In this function, we use an if statement to see when the meteor's position on the y-axis is less than or equal to the screen height. We put a minus in front because we need the bottom of the screen. When the meteor gets here, we can destroy it. We do this using destroy and in parentheses the game object we want to destroy. We call the function in the update method. When we test this, we see that the meteor disappears as soon as it hits the bottom of the screen. Thanks for watching. In the next lesson, we're going to make the meteors fall at random locations from the top of our screen. I hope to see you back in the next lesson. Please like and subscribe, so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development.